Right, so in the last few weeks we have practiced solving equations, straightforward linear ones, which have just got one unknown, like 4x plus 6 equals 12. Quadratics, where we've got x squared, x's and numbers equals 0. And also simultaneous equations where you've got two unknowns, x's and y's usually, in the two equations. Or most of the practice we've done, you've been given the equations. So in this last little section today, I just want to practice questions where you are given the problem as a context and you have to form the equations. So we're not going to spend the time solving the equations, although if there is time in the lesson you can go back and do those. I just want to get to the point where we create them. So this first one, each side of a square is of length 2x plus 3y centimeters. So straight away I'm looking at that and seeing two unknowns. So immediately I'm thinking this is going to end up with a pair of equations, simultaneous equations that we need to solve. So it's a square, so I know that in a square the sides are all the same length. So if that is 2x plus 3y, so is that, and so is that, and so is that. And I know that the perimeter of the square is 62. So I know that to find the perimeter, I need to work out the total distance around the outside of the shape. So if I know that that is 2x plus 3y, and that is 2x plus 3y, and so is that, I know that if I add those together, it's going to equal 62. So if I write 2x plus 3y plus 2x plus 3y plus 2x plus 3y plus 2x plus 3y, it must equal 62. So that's formed my equation. I can now simplify that. I got 2x, 4x, 6x, 8x, and I got 3, 6, 9, 12y equals 62. And that's as far as I can get with that because I've got those two unknowns. So that's my first equation. And then I've got a second bit of information here. It's a regular octagon. Regular means all the sides are the same length. Okay, so regular means just like a square. All equal length sides. So that's x plus 2y, so is that, so is that, so is that, and so on all the way around. So I'm going to have 8 lots of that. So another way of doing that would be to write it like that. So like I could have written that as 4 bracket 2x plus 3y equals 62, and I ended up with the same thing. 4 2s are 8x plus 4 3s are 12y equals 62. But because there's only 4 sides, I thought I'd set it out in that most basic way for you to get your head around it. And I could write that in a full length, but just to save space I'm going to do it this way. So I'll have 8x, 8 times x is 8x, plus 16y equals 72. So my simultaneous equations would be that one, formed from the square, and 8x plus 16y equals 72 from that one. So that's my pair of simultaneous equations, and from there then I would go on and solve them. Now if you remember from the work you did on Monday, in order to solve them you would make sure that the x terms are the same and then subtract. Well, in this case they already are, so all I need to do there is to subtract one from the other to solve for y. Okay, so that would be the first part of the question. The second part of the question would then be solving it. Question 2, we have done this one recently, okay? So it might be worth pausing here and seeing if you can do that on your own. William has n marbles. Lois has 4 times as many marbles as William, but she has now lost 23 of them. Lois still has more marbles than William. Write down an inequality in terms of n to show the above information. Use your inequality to find the least number of marbles that William may have. So let's form our inequality. We know that William has n marbles. If Lois is 4 times as many, she'll have 4 lots of n. But she's lost 23 of them, so out of that 4n quantity, we have to take out 23. And we know that Lois, so if that question said Lois still has the same amount of marbles, then we would say that that must equal n. Because this is saying Lois still has more marbles, then the inequality would be 4n minus 23. The number of marbles Lois has got is greater than the number of marbles William's got. So that's the inequality in terms of n, and then we go about solving that. So first of all, we would either add 23 to each side to get rid of that, and then take n from each side to get rid of that, and so on. So that first one was a simultaneous equation, the second one was an inequality, the third one, looking at what we did yesterday, is clearly a quadratic. So Aled has 3 concrete slabs. You'd have a lot more space on the real exam, by the way, than I've given you here. 3 concrete slabs. 2 of the slabs are square, with each side of length x meters. So I've got square of length x, which means they're all of length x. So I've got one of those, and I've got another one of those. The third slab is rectangular and measures 1 meter by x plus 1 meter. So I've got another one then, which is 1 by x plus 1. The 3 concrete slabs cover an area of 7 square meters. So the area of that one added to the area of that one added to the area of that one equals 7. So the area of this one is x times x. To look at the area of a rectangle or a square, it's length times width. So that'll be x squared, plus the area of this one, which will be x squared, plus the area of this one, which will be 1 times x plus 1, and that equals 7. So I've got x squared plus x squared is 2x squared, plus x plus 1 times 1 is 1 equals 7. So look at what I'm aiming for. I've got 2x squared, I've got it, plus x, I've got it, minus 6, well I haven't got minus 6 equals 0, I got plus 1 equals 7. So in order to make that equals to 0 now, I need to take 7 off each side. So if I take the 7 and take the 7, so I'm showing that I'm doing that, then that will give me 2x squared plus x minus 6 equals 0. And then part B of that question would then be getting you to solve that equation. If it said giving your answer to 2 decimal places, you know you'd have to use the formula. If it didn't, then you know you'd have to do that by factorizing first. What I'd like you to do now is, if we pause it for a short while and see if you can figure these two out yourselves. Now question 4 there, you should be able to do it similar to the one that I've just done with you, and for question 5, if you find your quadratic notes from yesterday, sorry, you won't see that, will you? Because it was on the video, I didn't actually give you that copy. The area of the trapezium is there. Okay, so the area of the trapezium is half the sum of the parallel sides multiplied by the distance between them. So jot that down quickly, or get the cover teacher to write it on the whiteboard, and you can refer back to that. So question 4, question 5, you should be able to have a go at. Question 6, similar to yesterday, there isn't a context, but you just have to get that in the form ax squared plus bx plus c. Question 7 is an isosceles triangle, so you need to remember what the relationship is for an isosceles triangle in the sides, and you can have a go at those other ones as well. So if you work through those, if the cover teacher can pause the clip, I'll carry on working through them, and then if you get stuck later, the cover teacher can run the video clip. Okay? Good luck. Okay, so the first one. 2 different squares are constructed. The side of the length of the smaller square is x. The side of the length of the larger square is 3 longer than the smaller square. The combined area of the 2 squares is 22.5. So I've got 1 square of side x, and then I've got a larger square which is 3 centimeters longer, so that will be x plus 3. The combined area of the 2 is 22.5. So x squared would be the area of the smaller square, plus x plus 3 times x plus 3 would be the larger square area, equals 22.5. Okay, so I can't do anything else with the x squared. I can expand this using FOIL, so x times x is x squared plus 3x plus 3x plus 9 equals 22.5. A little bit of tidy work then. X squared plus x squared, 2x squared plus 6x plus 9 equals 22.5. I need to make it equal to 0, so I have to take 22.5 off each side, giving me 2x squared plus 6x minus, and let's just make sure I get this right, 9 take away 22.5 is minus 13.5 equals 0. So if we look now at what they're wanting us to show, I can see that everything in my equation has been doubled to get that. And when you do something to an equation, so long as you do it to every part, so if I double everything, I get 4x squared plus 12x, that should be not x squared, minus 27 equals 0, which is what we were aiming to get. So the area of a trapezium, half times the sum of the parallel sides times the distance. Okay, so that's what's given to you on the front. That's A, that's B, that's the distance between them. And I know that the area is 25. So half times A plus B, so x plus 1 plus x plus 2 times the height equals 25. I'm going to get rid of the fraction by timesing by 2, and I'm going to tidy up what's in there. So I got x, 2x plus 3 times x equals 50. So I've times by 2 to get rid of the fraction, which means I have to times that by 2. I've tidied up inside there by adding the sides together. So x plus x is 2x, 1 plus 2, 3. Now I'm going to get rid of my bracket. So I'm going to do x times 2x is 2x squared, plus x times 3 is 3x equals 50. Look at what I'm aiming to get. I've got the 2x squared, I've got the 3x. I don't have the equals 0. I need to subtract 50 from each side, and then I will get and then the second part of that question would be to solve that quadratic equation. Question 6. Use the quadratic formula to solve. So I need to expand that first of all. So I've got 5x plus 3, 5x minus 3 equals 19x. So it's not equal to 0. It's not in the form ax squared plus bx plus c equals 0. So using FOIL first, 25x squared. Then the outside would be minus 15x. Then the inside would be plus 15x. Then the last would be 3 3s and 9 minus 9 equals 19x. So I've got 25x squared minus 15x plus 15 will go. So I've got no x, minus 9 equals 19x. I know I need it in the form ax squared plus bx plus c equals 0. So I have to take the 19x off both sides, giving me 25x squared minus 19x minus 9 equals 0. A is 25, B is minus 19, C is 9. I know I'm going to have to use the formula in order to solve that. Question 7. Diagram below shows an isosceles triangle and a square. The perimeter of the rect triangle is 19. Use an algebraic method, not trial and improvement, to find the value of x and the value of y. So I've got x's and y's. That means I know that it's simultaneous. So for the triangle, because it's isosceles, I know that if that's 2x, that's 2x as well. So for triangle, I've got 2x plus 2x plus 3y gives me the total distance around the outside, which is the perimeter, which is 19. I can tidy that up. 2x plus 2x is 4x plus 3y is 19. So that's my first equation. For the square, because it's a square, I know all the sides are the same, so that means that that must equal that. So I have 6x minus y equals 12. Then for the work you're doing on Monday, you'd multiply this equation by 6 to make that 24. Then you'd multiply this equation by 4 to make it 24. So they're the same, and then subtract, and off you go. And then the last couple. A rectangle has sides of length 2 bracket 3a minus 7 and 5a plus 4. Form an expression in terms of a for the perimeter. So the perimeter is the distance all the way around the outside. So I'm going to have 2 lots of that. And 2 lots of that. And it's not an equation, it's not telling me what the perimeter comes to, so I've just got to simplify this. 6a minus 14 plus 6a minus 14 plus 5a plus 4 plus 5a plus 4. I can just remove those brackets because to all intents and purposes you just multiply it through off by 1. 6a, 12a, plus 5 is 17, plus 5 is 22. So I've got 22a, minus 14 is minus 28, plus 4 is minus 24, plus another 4 is minus 20. And that's as far as you can go. It's not an equation, so you can't simplify it further than that. Well, you could take a common factor out, but there's no need. Finally, show that the triangle below is not a right-angled triangle. Okay, I know all the angles. I know all the angles have to add up to 180. So 5x take away 17 plus 2x plus 9 plus x plus 20 must equal 180. Simplify. 5, 6, 7, 8x, and then I've got minus 17 plus 9 plus 20 is plus 12 equals 180. Take the 12 off. 8x equals 180 minus 12, 168. Divide by 8, where x is 21 degrees. So I know that x is 21 degrees. I've got to show that it's not right angled. So in order to do that, I've now got to work out what each of these values is, each angle is. So 5x minus 17 will be 5 lots of 21, take away 17. So 5 times 21, take away 17. So that angle is 88 degrees. This one will be 2 lots of 21 plus 9. So x is that. So that's going to be 42 plus 9 is 51. And this one is going to be 21 plus 20, which is 41. So angles are 88, 51 and 41. None are 90 degrees. So it's not a right-angled triangle. Okay, so that's all the algebra that we are going to be covering. I've gone through already in the first clip for this lesson all the stuff that you need to take home with you. It's really important that you give those practice papers time. Use your notes when you get stuck. Go back if it's a third question, for example, and you can't recall it. Well, go back, look at your third notes, work it out. So don't just set aside an hour to do that. Make sure that you build up and work through that throughout the week. And then that first double Monday you come back, I'm going to be giving you a similar set of questions as a progress check. So do lots of work over Easter. There'll be time for you to have fun as well. And I'll see you in a couple of weeks.